Okay, we're going to talk about increasing and decreasing functions. So, in order to find out a lot of this information, this is lesson 4.1. Okay, they've given us a function, we'll call it a. Y is equal to x cubed plus 3x squared minus 2. This idea is very, very similar. In fact, it is pretty much the same as increasing and decreasing velocity. Okay? If you guys remember with velocity, if it is positive, that means our velocity is increasing. And if it is negative, it means that our velocity is decreasing. Okay? And what I mean by it, I mean the derivative. So if I'm looking for, this is, let's call this f at x instead. F at x. If we're looking at f prime x is greater than 0, then we're increasing. And if f prime x is less than 0, we're decreasing. The same goes when we graph our derivative of the function. Okay? If we have numbers that are greater than 0, that means we have an increasing graph. And if we have numbers that are less than 0, that means we have a decreasing graph. Okay? It's a little similar to advanced functions when you guys went through that. What we're going to do is we're going to derive this function, find out its critical values. Okay? And critical values can be local, minimums, or maximums. And what we mean by local is because before we talked about extreme. Okay? Well, in these functions, we don't have intervals. Okay? These functions are just going to go on forever. And say we have a function that looks like this, well, there is not going to be one maximum or one minimum because this goes up and down forever. But in the neighborhood, specifically this area here, we're going to have a local maximum and a local minimum. Okay? And when we derive these functions, these critical values are when our f prime x is equal to 0, or in other words, the slopes of our tangents are 0. That's when these points are going to happen.
Sorry. Second one, should it be less than?
Yes, 100%. Thank you. So, what we have from there is these critical points will help us decide where our functions are going to be increasing and decreasing. Because we know at those points, their slopes of those tangents will be 0. Okay, so let's say we draw a tangent line in red here. We're going to have two tangent lines. This one's going to be horizontal. This one's going to be horizontal. So we know we have slopes of 0. But in between that, I've now drawn the graph already. What types of tangents are we going to have? In this case, if we're going left to right, we're going to have an increasing tangent. Okay. Same idea. We'll have a decreasing tangent here in between. And finally, we'll end off with another increasing tangent. Okay. And in which case, that means we're increasing to the left of this maximum, or local maximum. We're decreasing between the maximum and minimum. And to the right of this minimum, we're increasing again. Okay? So we're going to derive this function to find out points of increase and decrease. And what we mean by increase and decrease, we mean their y values. Okay? Because on our x values, we're normally moving from left to right. Our y values, we talk about increasing with those movements. We're moving left to right. Are we increasing in the y-axis, or are we decreasing in terms of the y-axis? Okay? So, we have our function again above. We're going to find f prime x. F prime x is going to give us 3x squared plus 6x. Okay? And we want to find our critical values. That's the important stuff here. So we're going to set this equal to 0. 3x squared plus 6x. Well, I can take a common factor of 3x out of here. We're left with x plus 2 is equal to 0. Which means our two critical values in this case, and we could have more or less, are x is equal to 3 and x is equal to negative 2. Okay. So that means we have some function that has critical values at 0 and negative 2. Now what we're going to do is we're going to figure out if it's decreasing to the left of negative 2, because these being our critical values, let's again draw, oops, let's do that in black. Our Cartesian plane here. Well, we have a critical value at -2 and another one at 0. So we need to figure out, are we decreasing at 2? Are we decreasing or increasing after that? And are we decreasing or increasing after that? And of course, are we increasing before -2? What we're going to do to solve this is we're just going to take a value before -2 and plug it into our derivative formula. If we end up with a negative number, we know we're decreasing. If we end up with a positive number, we know we're increasing. Okay? So, before -2, in other words, when x is less than -2, let's use a nice value of -3. So when x is equal to -3, we'll put it into our derived function f prime at -3 will give us 3 -3 squared plus 6 times -3. This gives us 3 times 9, which is 27, minus 18. We get 9. Okay. What's important is this is a positive term, which means our graph is doing what? Increasing. Our graph is increasing up until the point of 2. Now, after 2, does it start to decrease or does it keep increasing? Now, you might think, well, how does it keep increasing? If you guys remember your cubic functions, you can get a cubic function that looks like this, plateaus and then it increases again after that. So we still have to figure out, usually we would think it decreases, but it completely depends. So now our next value we need to find when x is between, not 0, but -2 and 0. So when x is greater than -2 but still less than 0, because we know we have another critical point at 0. Well, again, I'm going to choose a value. Let's go with when x is -1. So f prime at -1 is equal to 3 -1 squared plus 6 times -1. This gives us 3 subtract 6, and in which case we get a -3. And what's important is we're negative. So what that means is after 2 we are decreasing. Okay? We know we have that, and we're going to decrease. I don't mean to cross 0, but here's going to be another critical point. And again, we need to find out when x is greater than 0. In other words, let's just use when x is equal to the value of 1. F prime 1 is equal to 3 squared plus 6. Quickly looking at this, I already know I'm going to be positive here. We're left with 3 plus 6 is 9. So, again, a positive value. So this represents some form of that function, what we've drawn here. We were increasing, then we decreased between our two critical values, and those critical values being 2 and 0, and then we started to increase again after 0. Okay? This function could be anywhere along this graph. I just chose to put it near the origin. Okay? It could be, this is a representative of any type of function that looks similar to this. Now, a lot of times what they'll do is represent this as a chart. Just make a chart here. We have 4. Oh, that's going to be all the way up here, I think. I apologize. I thought this would end up at the bottom. Come on, chart. Okay. And the chart they've made here, what they do is the value of x. And when we're talking about this, we're talking about when x is less than -2, which we talked about. When x is between 0 and -2. And finally, when x is greater than 0. Is our function, now they use Lebanese notion, we can always use our function notation. When f prime x is equal to our equation, they wrote the equation 3x times x plus 2. That's hard to see. Is f prime x at -2, is it greater or less than 0? Is it increasing or decreasing before -2? Anyone remember? Increasing. So that means it is greater than 0 at that point. f prime x between here is less than 0, and f prime x again is greater than 0. So our slopes of our tangents, we're going to say slopes, in this case are positive, negative, positive, and value of y. The value of our y-axis is increasing, decreasing, and increasing. Okay, so that would be kind of using a chart to represent all of these things.